This is kind of neat. So let's suppose I had this polynomial and I wrote it in its factored form. I had x, which is really x minus 0. I had x plus 2 squared, which means I have an x plus 2 and another x plus 2. I have a multiplicity there. And then I had an x minus 3 cubed. X minus 1, excuse me, cubed. X minus 1, x minus 1, x minus 1. So multiplicities, the degrees tell us something, okay? It tells us that where my 0 would be, let's say this is the x-axis. If it had a degree of 1, it's going to cross right through at that 0, like that. It's just going to cross right through it. If it has an even degree, like a degree 2 or degree 4, it's going to touch. It's going to kind of look like this on the x-axis. Remember, to go through the x-axis, you're a real 0. But if you touch it, it's going to kind of, depending on where it comes from, if it comes from the bottom or if it comes from the top. So this would just touch and then come back up if it's a degree 2. If it's an odd degree bigger than 1, odd degree greater than 1, then it's kind of going to do like a cross with a wiggle. Call it cross wiggle. So again, if this is our x-axis, it's going to kind of like, if this is my 0, it'll like kind of dance, do some kind of dance. Whereas for degree 1, it just strictly goes right through it. So let me show you that on what we have right here. Okay, so this x is degree 1. This x is degree 2, and this is degree 3. So this is my zeros, my x-intercepts are at 0, and at 0 it has degree 1, so it's going to cross right through it. This 0 would be negative 2, and it's an even degree, so it's going to touch the x-axis at negative 2. And then this 0 is a 1, but it has an odd degree, so it's going to do a little wiggle at 1. Now, if you remember back from a few lessons ago, we learned about something called end behavior. And end behavior was what the A coefficient in front is. If it's an odd degree, it would start down and end up, or it starts up and ends down. It was probably one of your favorite homeworks. So what I'm going to look right now is I'm just going to count to see how many degrees I have. This is 3, 4, 5, 6. This is a degree 6, and it's positive, so I know it's going to start up and end up. So if I were to just give a quick sketch of this polynomial right here without even putting it in my calculator, I'm going to go to, here's 0. I'm going to put all my zeros on the x-axis. 1, and then negative 2. Okay? And I'm going to start my graph up, and I know I'm going to end up. Okay? And we're just sketching it. We're not looking to see how high it goes. We just want to give a little quick sketch. So at negative 2, I'm going to touch it. I'm going to come down and come up. I'm going to touch it, make that U shape, or upside down U, depending on where we're going. Now through 0, I'm going to cross through it. And then through 1, I'm going to kind of wiggle myself through it. Now again, it's not a perfect graph. We can definitely look to see what this looks like on the calculator, but it'll give a good picture here. So let's see, this is, we'll leave it in factored form. X times x plus 2 times x minus 1. And let's see what it looks like. Well, it is not showing a pretty picture at all. What did I type? What in the world did I just type? Something went terribly wrong. Let me zoom out. Hold on one second. Okay, well, it's not doing what I want it to do right now, and I'm not quite sure why. Oh, I know, because I'm not in real form. That's why. Woof! I gotta get my calculator back in the real form. I'm in A plus BI form. Sheesh. Okay. Well, I'll show it to you in a minute because right now my thing, I'm going to figure that out. I don't know why it's not working, but that's essentially what you have to know, that it's going to touch down here, it's going to cross through, and then it's going to come back and squiggle through for 3. All right, so let's do something along the same lines. Sketch P of x equals -2 times x plus 4 squared times x plus 3 to the first times x minus 1 squared. And we're just looking at a quick sketch. Again, you could put it into Desmos, but we want to like see if we know what we're talking about here. So this has a degree 2. This is going to touch at -4. This has a degree 1. This is going to cross. And I wrote the 1 in there. I probably shouldn't have written it, but you know what I'm talking about. And this is an even degree also, so it's going to touch at 1 also. So let's take a look at what kind of total degrees do I have. 2, 1, and 2 make a degree 5. So the end behavior for degree 5 would be, oh, if it's a negative, actually, I was about to write it wrong. Negative would go up and then end down. And so I'm going to plot my zeros. This is -4, this is 3, this is 1. So -4, this is 3. Oh, sorry, -3, boom. And then this is 1. This one I don't need really. And again, not really worrying about height of things right now, like max and min height. We just want to kind of give a quick sketch. We know it's going to start up and end down. And at the -4, it's going to come up and touch. Then at -3, it's going to cross through. And then at 1, it's going to touch and come back down. Thanks. My husband is showing me that I got an AARP thing in the mail. That's how old I am now. I'm going to go to Desmos real quick and let's see if we can look at this equation on Desmos and see how it would draw it. Because I'm trying with Desmos, I really am. X plus 4 squared and then x plus 3 and then x minus 1, and this is also squared. So there we go. That's a little bit better. I don't know why my calculator was not being nice on the other one. I kind of want to give a good picture of this. So it looks like down at 150, is that where I'm at? Negative 150. So let's see. Let's change my x-axis to be -5. Yeah, let's go out more. -6 to 6. And then my y, that's a pretty good y. I can actually see it from there. But look at that. It's kind of similar to what we did. Actually, I might zoom out a little bit. So you can see we started up, we came down and touched, we bounced back up, we went through 3, bounced back up, came up to 1, and came back down. So we actually did a pretty good sketch. I have to figure out why my calculator's being mean to me about the other one. But you can always, like I said, double check it in the calculator. All right. Last 2 examples. And this one is kind of see-through, so I need to do this. All right, these are really, really, really important, solid last 2 examples. They are going to give you a polynomial. 6x to the 4th plus 7x cubed minus 12x squared minus 3x plus 2. And they're going to ask you for the following things. They want you to list all the possible rational roots. Then they want you to use the graph to eliminate possible zeros. I'll explain what that means. And then they want you to find all rational zeros and factor. Okay, so there's a theorem called the rational root theorem. It's very easy. I just didn't want to write it all out. It's not that hard. But it literally says that all of your rational roots are in the form of P over Q, where P is all the factors of this last term here, and Q is all the factors of this first coefficient here. So here's what I mean. So I write P and then I write Q. And I write all the factors of P. Now, you would want P to be in front and Q to be in the back, but that's not how it is. P is over here, all the way at the end, and Q is in the front. So P, all the factors of P, factors meaning like what can divide into it. So the only 2 things that make a 2 is 1 times 2. So put plus or minus 1, plus or minus 2. Those are all the factors of P right there. Now you do the same for 6. You list all the factors of 6. And I try to go in order. I go 1 and 6, then I go to the next number, 2 and 3, and then you'll eventually meet the middle. Plus or minus 1, and then I leave some space, plus or minus 6, plus or minus 2, and plus or minus 3. Now the rational root theorem says that the possible, not the roots themselves, but the possible rational roots must be in the form of P over Q. So what you would do is you would actually write every P and put it over every Q. So 1 over 1 is plus or minus 1. 1 over 2, plus or minus 1/2. You literally put every P over every Q. 1 over 3, plus or minus 1/3. 1 over 6, plus or minus 1/6. And now we do the 2. 2 over 1, plus or minus 2. 2 over 2. Well, 2 over 2 is 1, so I'm not going to write it again. 2 over 3. And then 2 over 6, which is 1/3. These right here are the possible rational roots. And you leave it just like that. Plus or minus 1, plus or minus 2, plus or minus 1/2, a third, a sixth, and 2/3, with the pluses and the minuses in front. Now, what my teacher used to make us do is we would have to synthetically divide each one of those in. So that would be 2, 4, 6, 8, 10, 12 times that we were synthetically dividing. 12 times. Until we would find one that works, until we found one that got me a 0. And that was a pain. So we're going to kind of cheat the system here, and we're going to try to use a graph, use like Desmos, or use something to find some real zeros. So let's see if I can find. Let's try, let me go back to a graph here. Let's use Desmos since Mr. Calculator is being mean to me. 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2. Now, I see a great amount of zeros, to be honest with you. I've kind of already got all my zeros. Look at that. -2, -1/2. Gosh, Desmos is so pretty. 0.333 and 1. Well, I'm going to use the one that I know are like without fractions or decimals. So -2 and 1. Those are whole numbers. So let's use those where they're integers. So I know I have -2 and 1 as zeros. Using a calculator or using Desmos. And now it says, find all rational zeros and factor. And I'm going to tell you, you have to show me this step. You have to show me on the midterm. So that's why we're working this out. So we're going to use these two and we're going to divide them synthetically into there. So we know that these will work. So I'll start with -2 into 6, 7, -12, -3, and 2. And I'll do my synthetic division. Trying to go fast, seeing if I can go fast with my headache. All right, and now this, I have another 0, 1. I'm going to synthetically divide this by 1. And remember, we're now at a cubic function. So 6, -5, -2, 1. And I'm going to synthetically divide it with the other 0 I had, which is 6, 1, 1, -1, -1, 0. And now I'm at a quadratic. And once I get to a quadratic, I can factor this. I can do quadratic formula. This one's actually factorable. 6x squared plus x minus 1. Two numbers that multiply to -6 but add to the middle of 1. This is how I do it. So I put x and x, two numbers that multiply to -6 but make 1. Oops. Is +3, -2, and then because there's a 6, I divide that by 6 and divide that by 6. Look what's happening. So this is reduces to 1/2, and this reduces to a third. Interesting. But I have to write it in a factored form. So you just bring that 2 up in front of the x. So this would be 2x plus 1. And then bring this 3 up in front of the x. This would be 3x minus 1. Those are the two factors for the quadratic. But what were the other zeros I had? Well, I had this guy. Let's write him. X minus 1. And then I had this one. X plus 2. So this is the factored form of P of X. And then these are all your zeros. negative 2, 1, negative a half, set that equal to 0, positive 1/3, set that equal to 0. These are your zeros, depending on what they ask you for. But see, it's not that hard. So we use something called the rational root theorem, where you list all the factors of P, plus or minus 1, plus or minus 2, all the factors of Q, and you get all these possible combinations that could be your roots. And look at that, 1/3 is in there. Negative 1/2 was in there. 1/6 wasn't, but we didn't know that. Thankfully, I didn't make you do 12 different synthetic divisions like my teacher used to make us do, but I used calculator or Desmos to actually just find some real ones to make it a little bit easier for me. All right. So we're going to do that one more time like that. Oh, and that's what I did wrong. Look at that. I knew I was like, I didn't even write down the rational root theorem, but I've just went into it. All right, let's go over that one more time. Good old rational root theorem and using that. Okay, so let's find all rational zeros of P of X equals, make sure this is not the same one. It's different. 6x cubed minus 5x squared minus 7x plus 4. All right, this will be our last one. Hopefully it'll make sense. And factor. And factor. Okay, so one more time. The rational root theorem says that all of rational roots are in the form of P over Q, where P is this guy's factors and Q is this guy's factors. Okay, so we write all the factors of P. Plus or minus what? Plus or minus 1 and plus or minus 4. And what other number can go into 4? What other numbers make 4? 2, right? 2 times 2, so plus or minus 2. Then we write all the factors of Q. 6 is plus or minus 1, plus or minus 6, plus or minus 2, and plus or minus 3. So P over Q must be a rational root. So I need to put all my P's over my Q. So again, I start with the first one and then I put it over and put it over and put it over. So plus or minus 1 over 1, plus or minus a half, plus or minus a third, plus or minus a sixth. Now I go to the 2, plus or minus 2 over 1 or 2, plus or minus 2 over 2. I already wrote it, 1. I'm not going to write it again. Plus or minus 2/3, plus or minus 2/6, which is 1/3. I'm not going to write that again. Plus or minus 4 over 1. 4 over 2 is 2. 4 over 3. And then 4 over 6 is 2/3, so I'm not going to write that again. So that is 2, 4, 6, 8, 10, 12, 14, 16. There are 16 possible roots. And I'm telling you this, oh my gosh, I had a lovely math teacher in high school, but she would make us do every single one of these synthetically into here. I mean, that's why you get really good at it. But the trick is, again, find at least a 0, again, using Desmos. Put that into Desmos, find an x-intercept. I'm sure you'll be able to find all of them, but you have to prove it to me synthetically. You have to. That's the only way I'll accept it on your midterms. So let's, use your calculator or Desmos. And I'm going to give you the one that I found in my notes here. I found -1. -1 worked, okay? Which, by the way, that's the trick you always try. You always try the ones. You hope they will work. So we're going to synthetically divide by 1. So synthetically divide, or by -1, excuse me, into 6, -5, -7, and 4. Yay! And I got out a quadratic because this was degree 3. And then once you get out of quadratic, you can do quadratic formula, but this is factorable. And I just want to go over again factoring this because I think everybody gets scared, but 6 times 4 is 24. So what multiplies to 24 but adds to a -11? What two numbers multiply to 24 but add to a -11? So that would be -8 and -3. And then because there's a 6 in front, you divide this by 6 and this by 6. Reduce it. 8/6 is 4/3. 3/6 is 1/2. And then bottom up. Bring that 2 in front of the x. Bottom that up. So 3x minus 4. This would be written as 2x minus the 1. And then don't forget the one that you found from here. X plus 1. This is the factored form of that polynomial. So that, my friends, is it for tonight. Let me give me my screen.